Welcome to our review of the scientific method. If you're interested in taking your own notes as we go over these parts of the scientific method, you can find a resource in Google Classroom. If you click on your classwork tab and scroll down to our unit about the scientific method, you'll find this review that'll have this video posted to it, as well as this PDF file. This PDF file includes each one of the slides that we'll go over today, as well as some room for you to write down your own notes if you wish. Taking your own notes is not required, but I know that some students like to have copies of notes or want to take that extra notes of their own as we go through things. So if you'd like to, that's a resource that's available to you. Scientists generally think of the scientific method as a set of steps to carry out your experiments. These steps can be carried out in lots of different fashions. They can go through some loops and some cycles as tests uncover new evidence that wasn't expected and they revisit and revise. But it generally begins with a question and the variables that they need to be thoughtful of. Then scientists state what they expect to happen in their hypothesis. They want to say it beforehand so that if it actually happens, I guess, they can say, well, we knew it would come out this way. Here's why, here's what we learned, here's how it supports it. Or if it doesn't come out the way that they expected, it gives them a chance to revise and revisit and think about what may have caused the outcome to be different than they expected and what they might revise or change about their experiment. They also include a detailed set of instructions about how to conduct their tests so that someone else can do it the exact same way when they try it a second time. All of this stuff's identified before they actually collect their data and observations. Of course, they do those steps so that they have things that they can quote and point to as they come up with their conclusion or explain what they learned. Today, we're just going to focus on those sections of question, variables, and hypothesis. A scientific question will identify the two things that they think might be related. We call those two things variables, and specifically the independent and dependent variables. A variable is essentially anything that could change or could be different or mixed up in your experiment. The independent variable is sometimes referred to as manipulated. Manipulated is a fancy way of saying changed. This is what you're purposefully changing in your experiment from trial 1 to trial 2 to trial 3. It could be 2 things or 3 things that you're comparing as well to see how they perform on a set of tests. The dependent variable is sometimes thought of as the responding variable because it responds to what was changed in the independent variable. It's what you're measuring. This is something that you can quantify with numbers or qualify, describe. The outcome or what happens in the dependent variable, your measurements, responds or depends on what you did or what was changed about the independent variable. Let's take a look at an example. In this example, someone wants to know, how does the amount of sunlight affect the height of a plant? Think about what 2 things the question is talking about. There's 2 big ideas here in this question. See if you can come up with them. Did you come up with sunlight and the plant height? Those are 2 of the key ideas that's in the question. How does the amount of sunlight affect the height of a plant? Now, to determine which one's the independent variable and which one's the dependent variable, think about what would be changed in this experiment and what would be measured. Would you change the sunlight or would you measure the sunlight? Would you change the plant height or would you measure the plant height? The independent variable in this example is the amount of sunlight. That's what you would change or manipulate about each one of these tests. What you would measure, or what would respond to the amount of sunlight, or what would depend on the amount of sunlight, would be the plant height. Let's take a look at another example. How does the type of deodorant affect body odor? Think about what two things they're talking about. Think about what thing is changed and what thing would be measured. Did you say that the independent variable would be the type of deodorant? Did you say that the dependent variable, or what's measured, is the body odor? One last example. How does the amount of sleep you get affect your grades at school? What are the two big ideas in this question? Which one is measured? Which one is changed? See if you can pick out the independent and dependent variable. Did you come up with amount of sleep as the independent variable and your grades as the dependent variable? In this example, if they get different amounts of sleep, they would measure the grades at the end. A hypothesis is their written expectation for how things will occur in the experiment. They write down exactly what they expect to happen before they collect any data. That way they can actually say, this is what I expected, here's the evidence that it occurred, as opposed to, here's what I got as the data, this is what I thought would happen. You want to make those predictions beforehand. Your hypothesis should include the independent and the dependent variable, the outcome, or the effect you expect to see. At the end of the experiment, we go back to the hypothesis and evaluate it. Did our data that we collected actually support what we expect to happen? Did it reject or disagree with what we predicted would happen? Or did the data really not tell us one way or the other? We'll focus on this a little bit later as we focus on the conclusion, which is what we're going to add in this year in 8th grade. A good hypothesis states what change in the independent variable and what that will do to the dependent variable. So think about, what would you change about the independent variable? Is it increasing? Is it decreasing? Is it one of your specific things you're testing? What would that do to the dependent variable? When the independent variable goes up, what would you expect to happen in the measurements you collect? And then, of course, we also end it with a reason. Why did you expect this? What evidence or things are you saying causes this to happen? And we usually write it in a format of if whatever your prediction about the independent variable, then whatever your thoughts on the dependent variable, and because of your reasons or research. So you can think of it as having three super important words: if, then, and because. And each one of those independent and dependent variables have a specific spot that it should be in. Let's take a look at those same three examples from our question and identifying variables. Our first one was, how does the amount of sunlight affect the height of a plant? We identified the independent variable, or the thing that we would purposefully change in this experiment, would be the amount of sunlight, and we would measure the plant height at the end. Remember to use the format of if something about the independent variable, then something about the dependent variable, and because of some reason, some knowledge, or some research. Try to write a hypothesis for this example on your own. I'll give you a few moments to try to get your thoughts in order. One example might look something like this. If there is more sunlight, then the plant will grow taller, because plants need sunlight to create ATP energy by photosynthesis. Did you have something about if the sunlight? Did you make a explanation of how the sunlight would change? My example says more sunlight. If there is sunlight would not be enough. You want to make sure that you make a prediction about what type or amount or change in the sunlight. If sunlight increases, if sunlight decreases, if there's less sunlight, if there's 8 hours of sunlight, then you want to make sure that you explain what would happen or what you expect to occur with the dependent variable. Here in my example, I said that the plant would grow taller. Taller is a measurement about the height. And then, of course, I include some previous knowledge and some reasoning to help support what I'm saying. Another example, how does the type of deodorant affect body odor? We identified the type of deodorant as a thing that we would change. In this example, we'd be looking at multiple brands or types of deodorant. And then body odor. What type of smell is left afterwards? So, remember our format. If something about the independent variable, this might be where you pick your favorite brand of deodorant. Then, what would happen with the body odor? And why? My example, if the deodorant is clinical strength, then there will be less body odor because it has a stronger formula. So here I make some sort of a statement about the independent variable, in this case a type of deodorant. This could be a brand. If the deodorant is Speed Stick, if the deodorant is Secret, then what would happen to that body odor? What would we expect? And then why? Our final example, how does the amount of sleep you get affect your grades at school? The amount of sleep's the thing that we would be purposefully changing or manipulating about our experiment. The grades would be how we would measure. Remember our format. If something about the independent, then this is our expectation for dependent and why. Take a moment and try to come up with your own hypothesis. It could look something like this. If someone sleeps 8 hours a night, then their grades will be better because they are able to concentrate better. There's one last thing that we need to think about as we're setting up our experiment, and that's our constant variables or controls. We want to really try to make sure that it's the independent variable is the only thing that could be changing our outcome or our measurements of the dependent variable. Scientists want to remove everything else. That way we can actually say that this thing makes something else happen or is responsible for something else happening. If there's lots of different things in the experiment that are changing, it's very difficult to say that this one particular item is what was responsible for the outcome. We call these items that we need to keep the same constant variables or controls, and we try to keep them the exact same for every single test and trial. Let's take a look at some more examples and see if you can come up with some constants. Here we're back to that first example of the amount of sunlight and the height of a plant. We thought that there would be more sunlight, and that would cause the plant to grow taller because of the energy they get through photosynthesis. What types of things might need to be kept constant or the same for each amount of sunlight that you're testing? Some examples might be the amount of water. If you give the plants different amount of water, could you really say for sure that it was the sunlight that changed their height? If you had different types of plants, if you had a sunflower for lots of sun and you have a green bean plant for less sun, can you really say that the height is a fair comparison? The amount of soil that's in each container, or possibly the time that you allow them to grow. Are there any other things you can think of? Let's take a look at another example. How does the type of deodorant affect body odor? We've got our independent, dependent, and hypothesis from earlier. Now let's think about what types of things would need to be kept constant or the same as we evaluate each type of deodorant and the amount of body odor that the person has after wearing it. Would we need to keep the amount of deodorant that you apply the same? More of one type might lead to less odor. How about the person that it's applied to? If one person might be stinkier than another person to begin with. How about the type of activity that they're doing? Would it be fair if one person was running a marathon and another person played video games? How about the way that you collect any sweat that might be produced? How would you measure the smell? What types of steps or things would need to be done the same for the sniff test or deciding if there's body odor? Our last example, the amount of sleep, your grades. Let's take a look at what things might need to be kept the same. Think about which ones you would keep the same. Some examples might include the person that is tested. It wouldn't be fair if one student sleeps a bunch and another one does not. One student might be a better student than the other one to begin with. What about the bedtime and wake up? Would it be fair if you change the amount of sleep and what time you go to bed and what time you wake up? 8 hours of sleep might be different from 8 a.m. until, or from 8 p.m. until 4 a.m. compared to 10 a.m. or 10 p.m. and 6 a.m. How about the pre-sleep routine? Would it be fair if one person takes a long bath and then the next test they do a bunch of exercise? What about the starting grade? What about the subject that they're taking? Would it be fair to do an amount of sleep in math class and a different amount of sleep before science class? You couldn't compare the grades in those two classes because they're different classes. We'll take some time in our first live class together, either Monday for my A students or Wednesday for my B students, to go through these together, answer questions, and provide help as it might apply to your experiment proposal project. Thanks for your attention. Feel free to watch this as many times as you would like.